Okay, let's move on to section 1.8. We're going to take a look at the application of the linear functions. All right. First of all, let's review the linear function. Right? Linear function, we can write it as f of x equal to mx plus b. And f of x represents function notation. So let's first of all take a look at all of these problems here. So as one up, determine if each relationship represents a function. So a function is a one-to-one relationship, which means it's one-to-one relationship. It is one relation, meaning one x value produces one and only one y values. So this is the essence of the function notation. If you look at the first table here, each x value here produces only one y value. This one, x equal to 2 produces y value 8. X equal to 3 produces y value 27. X equal to 4 produces y value equals 64. If you look at this, look like the function relationship should be f of x equal to x cubed. So the y value is always cube of the x values. Okay, and so it is a function, right? So function E. The second one is the y equals 3x squared minus 1. We call this quadratic function. You can also just pick x value. For example, so pick x equal to 1, then y value is equal to 3 times 1 squared minus 1. So that's 3 times 1 minus 1, which is 3 minus 1 to 2. So one x value produces only one y value. So you can also come up with different x values. You always end up with one y value. So this is also a function. And the third one is when f of x equal to x squared plus 2. Here we want to find out what is f0. f0, so replacing x here with the 0, so you get a 0 squared plus 2, which is 0 plus 2, which is 2. Okay. And f of 3, now the x value becomes 3. Okay. So go back to the function itself, replace x with 3. So 3 squared plus 2, and plus 2, that's 11. F of negative 2. So x value becomes negative 2. So we get negative 2 squared, adding 2. Negative 2 squared, that's 4, plus 2, that's 6. Okay. But again, it's a function because one x value creates only one y value here. And we're going to learn how to identify linear functions very quickly. So linear function should be appearing in f of x equal mx plus b. As long as you can turn into this form, then it's a linear function. Otherwise, it's not a linear function. Make sure the power for the x, power of x is 1. That's where the linear function comes from. Now, linear function, we call this function notation f of x, right? That's what we call function notation for mx plus b. And for the function is a one-to-one relationship. F of x is read as f of x. F of 1 is read as f of 1. The graph of the linear function is a line. It's a straight line. The linear function f of x equal mx plus b has slope m, y-intercept b. Those two are most important elements in the function notation. Now, determine whether the function f of x equal 2x cubed is linear. No, this is not linear because the power is 3. Okay, so this is a third-degree polynomial function, right? So, but it's not a third-degree polynomial function because the power here determines linear function is the first degree because the power for x is 1. So it's first degree polynomial function. If you look at the next one, f of x equal to minus 2x equal to 4. So the power here is 1, right? So it is first degree polynomial function. We call this a linear function. So the power of x determines the outcome. Okay, so now next thing, let's write a linear function in the standard form, standard slope-intercept form. Now here we are given 4 order pairs, and in order to find a linear function, we need to first of all find the slope. You can take any 2 order pairs, right? I would take the last 2. Because the last 2 has a positive numbers, which is easier to work with. 1, 4, and 3, 10. Take those 2 order pairs, label them x1, y1, x2, y2. Now slope is equal to y2 minus y1 over x2 minus x1. I'll replace y2, y1, x2, x1 with given numbers, so we get 10 minus 4 over 3 minus 1. 10 minus 4 is 6, 3 minus 1 is 2. Rather than get 3. So to find the slope, now we're using point slope form. Which is y minus y1 equals slope times x minus x1. Now we know x1, y1. x1 is 1, y1 is 4. And slope m is 3. Now replace all those 3 numbers in the point slope form. So y minus 4 equals slope 3 x minus 1. Now we distribute combine like terms. Y minus 4 equal to 3x minus 3. Now we're adding 4 from both sides of the equation. Then y equal to 3x plus 1. And we turn into function notation, right? So this y becomes f of x. So f of x equal to 3x plus 1. Okay. So that's how we get a linear function from this order pairs from the T table. This is what we call it T table. Now one more example on this. We are given 4 order pairs as well. And the first one, we call this the y-intercept because x is 0. So that means we know b is equal to 5. So the only thing we have to do is find the slope. We already know the b. So take the first 2 order pairs, 0, 5, and 1, 6. So label this x1, y1, x2, y2. And let's find the slope using the slope formula, y2 minus y1 over x2 minus x1. 6 minus 5 over 1 minus 0, so it's 1 over 1. That's 1. So now we know slope is 1. Y-intercept is 5. Using the function notation, f of x equal to mx plus b. So now f of x should be equal to m is 1 times x plus 5. So this linear function should be f of x equal to x plus 5. Okay. So be flexible about this. In this particular problem, we are given the y-intercept, so we can use it directly. Now let's look at the example 3 on this dosage problem. So dosage for medicine, it's linear with the weight of the patient. That's the minimum dosage onto which is added a per pound dosage. So you find that your dosage at a 110-pound patient is 48 milliliters. The brother's dosage at 170 pounds is 66 milliliters. We would like to have an equation that will relate the dosage to the weight of patient, providing the following things: definition of the x, including the unit, definition of the y, including the unit, equation in the form of y equal mx plus b, the units of slope, and the units of the y-intercept b, and imputation of the b. And what is the dosage for 145-pound patient? So I'm going to show you the detailed solution here. Okay, and I'm going to move on to another platform so we can look into this problem. All right, so now let's continue here. So first one, let's define the x values, right? So here the dosage depends on the weight. So for part A, the defined x will be the weight of the patient in pounds. Weight of patient. Unit is pound, right? All right, then part B is what is the definition of the y? So the dosage depends on the weight of patient. So dosage, that will be the definition of the y, and dosage is the unit should be milliliter. Or ml. And part C is finding the equation in the form y equal mx plus b. So we are given two order pairs here. First order pair is 410-pound patient, dosage 48 milliliter. The other condition is 170-pound patient and dosage 66 milliliter. Now we are actually given two order pairs. So based on those, you label this x1, y1, this y2. And we can find the slope first. Slope is y2 minus y1 over x2 minus x1. So that's 66 minus 48 over 70 minus 110. So this turned out to be 18 over 60. This turned out to be 0.3. And the unit for this will be milliliter, 0.3 milliliters. And remember, y value is the dosage in milliliters, and x value is the weight of the patient. Okay. And we're not done yet, right? So passive, we only know the slope for now, and then we can use a point slope formula to get the y value here. Okay, so we're gonna do y minus y1. So x1 is 110 pounds, y1 is 48. Slope we just calculate 0.3. And we do y minus y1 equals slope times x minus x1. Point slope form. So y minus 48 equals slope 0.3 times x minus 110. And from there, we're going to distribute it to the linear function. Our linear equation 0.3x on the right, distribute it 0.3 times negative 110 is minus 33. And from there, we're going to add in 48 from both sides of the equation. So y value equals 0.3x adding 15. So we get an equation in the form y equals mx plus b. So the unit of slope here, how big is the unit of slope? We already have it. It's milliliter per pound. So the unit of slope is milliliter. And the units of b and interpretation of the b. So the b value here is turned out to be slope is 0.3, the b equals 15. And we can view this b as minimum dosage, meaning no matter the weight of the patient, the minimum dosage will be 50 milliliter. So the unit of the b is a milliliter. And then the interpretation is the minimum dosage. Then part F is what's the dosage for 145-pound patient. Now, since we have the linear equation representing the relationship between the weight of patient and dosage, so the y value equal to 0.3x So an x value 145 pounds. And so replace x with 145, solve for y. Y's dosage 0.3 times 145, adding 15. And 0.3 times 145, that's I think it's 43.5, but we double check. 145 multiplied by 0.3, 15, 1 over 12, adding 1, 13, 1 over, so it's 43.5. Adding 15, that gives us 58.5 milliliter. That means for 145 pound patient, the dosage required is 58.5 milliliters. Okay, that's how we solve this. So let's go back to the PowerPoint. Let's continue from here. We'll take care of this dosage problem. So now another problem is that monthly service charge for the phone service, right? The long distance phone service has a base monthly charge and a per minute charge. Base monthly charge and per minute charge. You use 350 minutes in a month. The total cost was $32.50. When you are using 400 minutes in a month, the total cost was $36.5. We want an equation that will allow you to calculate your phone bill. So you define x including the units, define y including the units, find out the equation in the form y equals mx plus b, define the units of slope, find out the unit of y-intercept b, and then interpretation of the b. How much will your phone bill be if you talk for 540 minutes? So one more time, we're gonna go to the note, and I will continue from here. All right, so now first one, let's define x values. So definition of the x should be minutes used in a given month. Okay. And then the unit for the x will be minutes. So the monthly charge depends, total monthly cost depends on the minutes used. So the y value should be monthly cost, monthly charge. And then the unit here must be dollar amount, right? Dollar. And part C is finding out the equation in the form y equals mx plus b. So actually we are given two order pairs. First one is when you use 350 minutes, that x value, the total cost is $32.50. If you are using 400 minutes, then the total cost is $36.50. And we can view this as x1, y1, x2, y2. Again, so two order pairs, we utilize that, find the slope first. Slope equal to y2 minus y1 over x2 minus x1. So from here we get 36.50 minus 32.50 over 400 minus 350, and this is 4 over 50. So this turned out to be 0.08. Yes, $0.08 per minute. Meaning each additional minute cost 8 cents. Now from here, we can do x1, label x1 is 350, y1 is 32.5. Now we can slope, we know that 0.08, and use point slope formula. Let's come up with the equation of the function. So replacing y1 with 32.50, slope is 0.08, and x minus 350. Let's distribute it on the right. We get y minus 32.50 equal to 0.08x. 0.08 times 350, that is 28. Now from here, we are adding $32.50 from both side equation. Once we cancel that, so y value is by itself, we get 0.0x, 4.50. All right, so this is the equation capturing the relationship between the minutes used and then the total cost. We get that. So this is y equal 0.08 x 4.5. On the unit of slope, we already point out that it's going to be in dollars per minute. It costs 8 cents, $0.08 per minute. So unit of y-intercept b, it looks like this is fixed cost, right? $4.50 is fixed cost. So each dollar. Quotation of that is the monthly base charge or fixed cost, monthly fixed cost. So no matter how many minutes you talked, you have to pay $4.50. And how much will be your phone bill if you talk for 554 minutes? Now we have a equation here, and we are computing total cost for one x value equals 544 minutes. So now we place actually 544 minutes, and then we can solve for the y value, which is total cost. 0.08 times 544, 4.5. So 544 times 0.08 times 4 is 32, 33 over 32 adding 3, 35, 33 over 5 times is 40, 40 adding 3, 42. So carry down the two decimals, so it's $43.50 adding $4.50, and this turned out to be $48.02. So this is the phone bill for talking 550 minutes. And this is another application problem, similar to your home assignment. Let's go back to the PowerPoint. Let's finish up the last couple of slides. So now determine whether each function is linear. So power 1 non-linear because the leading power is 2. Right? This is what we call quadratic function. The second one is linear. That's right. And then the third one, if you look at it, we are given the y-intercept here. Y-intercept is -1. So b equal -1. And we can also generate the slope from this point to this point here. You go up 1 unit, go to the right 2 units, go up 1 unit, that's 1. Go to the right 2 units, half. So we know the slope is half. It's positive, so it's increasing line. So y equals mx plus b. Or you can say f of x equals mx plus b. So f of x should be equal to half of x. Adding -1 is -1. To find out the equation for this linear function. And now consider the following options. So if I for the summer job, maybe provides the following options. First one is a fixed monthly salary of $2,000. Second one is a base monthly salary of $800 plus a 10% commission of the monthly sales. So totally depends on your personality. So you are a people person, maybe you prefer the commission-based salary system. If you are a shy person, conservative person, maybe you feel like fixed monthly salary of $2,000 is better. But for the first option, f of x, right? This is a constant, so it's always going to be $2,000. For second option, so the monthly salary depends, includes 2 parts. 10% of the commission, 10% times sales, right? Monthly sales. We assuming monthly sales as X. Adding $800 commission. And those are 2 functions we are utilizing to to show the monthly salary in the linear model. But it depends on the depends on the functionality and other factors. You pick the quadrant options here. Right? So this is how we utilize the linear function to make decision in real life. This is a typical sales job. So you look into that and figure out a better option for yourself. Okay. All right. So now the last question, one more time, is a manufacturing company produced 2,000 units at a cost of 200,000, 4,500 units at a cost of 300,000. Each unit produced could be sold for $50. Assuming a linear relationship exists between the number of units produced and the cost. We find cost, revenue, profit functions given units of slope and y-intercept. The variable cost per unit, also known as marginal cost and fixed cost. The cost, revenue, profit when 10,000 units are produced. We need to find out break-even point, average cost per unit of producing 15,000 units, and the equation of the average cost per unit. We went over one of the similar problems from previous PowerPoint, but it's worth to do it again because it's fairly sophisticated problem. So let's do it here together. All right, so first one is taking care of the cost functions. So let's find out the cost function first. So we are given two order pairs here. In terms of 2,000 units production level, the total cost is $200,000. At a 4,500 units production level, the cost is $300,000. Now this is given two order pairs. We call this x1, y1, x2, y2. And y value represents the cost, total cost. X value represents units produced and sold. So now let's find out the slope first. Slope equal to y2 minus y1 over x2 minus 300,000, 200,000 over 4,500 minus 2,000. This is 100,000 by 2,500. And this turned out to be 40. So this means $40 per unit. That's a cost. Okay, we call this variable cost per unit. Now, once we know this, let's find out the equation first. So y minus y1 slope. From here, we will find out the cost function. Okay. So y minus y1, let's see what y1 is 200,000. Slope is 40, x minus 2,000. From here we distribute it, get y minus 200,000 equal to 40x minus 40 times 2,000, that's going to be 80,000. Right. Now we're adding 200,000 from both sides of the equation. The y value equals 40x adding 120,000. And put into real context. So y here represents cost function c of x, 40x adding 120,000. Here slope is 40. Y-intercept is 120,000. 120,000 here represents fixed cost. And 40 here represents variable cost per unit. So we take out the cost function. The cost function is equal to that. And let's go back and look at the revenue function. So the second part is the revenue function. Revenue function R of x. So each unit produced is sold for $50. So 50 times x. That will be the revenue function. And then the profit function. So slope here is 50 minus 7 equal to 0. And here the slope is $50 per unit, right? So this is $50 per unit. Y-intercept is if it's selling 0 units, you get $0. It's also $0 sign. Profit function is equal to P of X equal to revenue function minus cost function. So now we do 50x minus 40x. Make sure for the cost function in parentheses, adding 120,000. And distributing the 50x minus 40x minus 120,000. So simplify is 10x minus 120,000. So that's P of X. Profit function. This profit function slope M is 10. So this means the profit is $10 per unit. And the y-intercept B equal to minus 125. Meaning, if there's 0 unit produced or sold, then the net loss of $120,000. If 0 unit produced. Okay. So that's all 3 different functions here. That's part 1. Part 2 is variable cost per unit. We know that already. It should be $40 per unit. We get it from the cost function. We analyzed it earlier. It's $40 per unit. It's the variable cost per unit. Okay. And a cost, revenue, profit when 10,000 units are produced. Okay. So we just have to plug into each function properly when 10,000 units produced. So for the cost of 10,000 units, so it's going to be 40. And adding 120,000. So this is 400,000. Now is $120,000 cost. Revenue of producing units 50 times 10,000. Estimate is 500,000. And look at the profit producing 10,000 units. It will be 10 times 10,000 minus 10,000. That's 100,000 minus 100,000. So we get a net loss of the negative $20,000. Using 100,000 minus 520,000, you also get 820,000. Part 4 is break-even point. Break-even meaning no profit and no loss. That's what the break-even is. No profit. So you set in profit function P of X equals 0. That means 10x minus 120,000 equals 0. We solve for x. And adding 120,000 first on both sides of the equation. So 10x equal to 120,000. I'm now dividing 10 from both sides of the equation. So the break-even production level is 12,000. Units need to be produced and sold to break even. And the last part 6, is you want to find out the average cost per unit for producing 15,000 units, and then the overall average cost per unit function. You need to know For producing 15,000 units, what is total cost? 40 times 15,000, adding 120,000. Right. So plug into the cost function. Cost function is 40x. So 20,000, then we get 600,000, then 120,000. 720,000 total cost. If we divide this by 15,000, we get a average cost per unit. So dividing 720,000 units. And let's see what that is, right? We drop 3 zeros, 720 by 15. It's going to 72 and 4 times. That's 1560. That's 120. If you go into 120, it's 8 times. 8 times 15. So this is $48 per unit average cost. We look at the overall picture, average cost unit function. It's A of x, A of x. So it should be cost function by the unit produced. The cost function is 40x having 120,000 over x. And that gives us an instant average cost per unit at each fraction level. And that is everything on section 1.8. You can look into the exercise in the back of the class book to become familiar with the concept.